Welcome to TERC Tech Talks with your hosts, Zac, Elise, and Ken. Today's topic is ChatGPT Study Mode.
All right, so we are recording. Welcome to the first episode of TERC Tech Talks. I am Dr. Zac Alstad, and with me,
I am Ken Rafanan.
all right. And perhaps we should just start with a couple of introductions about who we are and what we plan to do here in this space. Does that sound good, Ken?
Oh, that sounds great.
All right, Ken, what do you want to achieve here?
Well, I think it would be fun to try out a few AI platforms and just see what they can do and see if we like them, don't like them, what we like about them for different educational uses. Mostly for like, can you use it with learners?
Yeah, sounds great. Sounds great. And just as a little bit of an introduction, so I'm again, as I had mentioned, I'm Dr. Zac Alstad. I work in educational technology. I'm very excited about how we can make these kinds of tools accessible to neurodiverse students. I'm interested in STEM education. Trying to make these systems work is a part of my passion. So hopefully, some of these AI tools can be made better through some of this effort. Hopefully, some teachers or practitioners out there might find some of these trials beneficial to what you do and to your practice. So you don't have to go through and try all these different systems. And so we're going to run it through its paces. We're going to see what happens, and yeah, well, we'll get to it then. Ken, do you want to introduce yourself first?
Yeah, like I said, I'm Ken. Been working on educational technology work for about 20 years now, and we're always looking for new ways to integrate technology into new ways of learning and seeing if we can get at some concepts that we haven't yet been really good at getting at. So, every new technology will have its disadvantages, but maybe we can find some advantages to get at some new ways of learning.
Right. Great. Okay, so before we do anything, let's just talk a little bit about what we're seeing here and what study mode is. So what is your understanding of it so far, Ken?
So this is just the very plain ChatGPT. I'm not logged in or anything. It's totally free version, and it's not in study mode yet. But I think what we can do is in the ChatGPT window there, we can just say turn on study mode.
Okay.
Worked before.
Yep, let's see what happens. All right.
Study mode, right? Zac, study mode just came out this week, so this is kind of one of the very first uses.
Okay, and then let's see if this is actually study mode. And why don't you go ahead and log in here, because that might actually be a literally different version of it, because sometimes it might just play along and say it's in study mode.
Should we check? Let's see what it'll like. Let's give it a simple question, and we'll see. Oh, well, that was not very study mode-ish, right?
So
like you were saying.
So this is a good tool for comparison of what it normally does. Okay, so if it is not in the actual study mode, it will literally just give you an answer. So let's bear this in mind as a baseline, essentially. Then why don't you go ahead and try and log in here. Now, so you do have to be logged in to use your account and to use some of the more advanced features here. So go ahead and go ahead and put study mode in first. So go to tools, and then go down, see study and learn. So when we see that little blue mark there, we know we're really in study mode. Notice that there are several other types of modes. You could do deep research. There's all kinds of other things going on in here, Canvas, web search, and sometimes it just automatically does web search. And so it's understandable that you might think it would go into some of these modes. It's kind of unclear as to when ChatGPT will do that and when it will not. So make sure that if you really want it to work, you dropped on this drop down here and go ahead and hit study and learn there. Okay, so before you do anything, what are you expecting to see, Ken, when you put this in? You had your equation.
Yeah, well, I'm going to expect not to see the answer right away. So I'll see. We'll see.
All right. So hopefully it's this time it will not give us the answer. Let's see what happens. Okay,
Yeah.
whenever you're ready. All right, here we go. Let's solve it together step by step. You've got this. A little bit of encouragement, right? So it sounds like in that pre-prompt they have some encouraging tone, some kind of thing.
I love think about the opposite of multiplying by 3. That's good.
Okay.
That's,
Yeah.
that's a pretty big. That's a good hint.
Sure. Okay. So what can we do to isolate x on one side of the equation? Note, so it's asking questions. I like this. That is asking questions.
Yeah.
Now, let's mess with it a little bit. Let's get some wrong answers in here, I think, and let's see what it does.
I think the opposite of multiplication is subtraction.
We'll see if it thinks of that as the inverse operation here.
All right, nice try. You're thinking in the right direction about doing the opposite operation, but here's a little clarification. The opposite of multiplying is actually dividing, not subtracting. Since the equation is 3x equals 12, and 3 is being multiplied by x, we can divide both sides by 3 to isolate x. Okay, so it gave you the step there. That's an important thing there, right? It gave you sort of the sub answer, right? Of what the next step is supposed to be, right? And so that's an important point about, do you want the student to find each sub-step? Because it looks like it is going through each step of the process here, right? And gave you the answer. So it'd be nice if it made you guess again. So you said subtraction the first time, well, why don't you try another time? You know what I mean?
Yeah.
So
I want to see what other. I'm going to ask if I can multiply by the inverse, and then see if they if it's stuck on division, for example.
Sure. Yeah, let's see what happens here. Okay. Oh, excellent thinking, Ken. All right. Multiply both sides by the inverse, the reciprocal of 3. That is 1/3. Does exactly the same thing. Okay, great. Okay. So
let's do it your way. What happens to 1? So now it's asking how do you multiply 1/3 times 3x?
So it sounds like it's sort of robust to other ways of doing it. It's not going to sort of force you down its own track, right?
Exactly.
Yeah, that's nice for sure. Okay.
Right. We'll see what it. Oh, but then it does it. It kind of pushed us along for simplify. Like so I gave it 3/3x, and then it just it's almost like it's a not quite very patient teacher. It's like, all right, let's move along.
Let's keep going, right? It's getting a little bit bored, right? So it sounds like it's not quite actually assessing your understanding, quote unquote. Like it knows what the steps are.
Yeah.
And it wants to go through the steps. It's fine if we go another way, but it wants to go to the next step as soon as possible instead of assessing, do you really get that, right?
Yeah.
And so
yeah, exactly.
And so it's moving right along here. It really just wants to keep going. Right?
Yeah, exactly.
Okay.
What does the right side equal? I think it equals 12/3. Let's see if it's. Oh, there it did it again. It's like, all right, I'm going to do the calculations for you.
Right. So it seems like it's so deep into its training that it's supposed to solve problems, right?
Yeah. Let's see why I have to plug it back in.
But it's a good habit, especially when you're still learning or working with some more complex equations. Think of it like checking your work on a math test. You plug x equals 4 back into the original equation, 3x, 12. Oh, yeah, okay, there we go. It works. So you know your solution. So it's doing a checking process. Would have been a lot better if you had the student sort of fill in the process of checking it, right?
Yeah.
And sort of in this interface, instead of like writing it out, like having the student actually write 3 times 4 equals 12, right? To actually check it. That's different than what it's doing here, right? It checked it for you.
Yeah, exactly. So I'm wondering, so it's like this interesting space, like for students or learners who are really struggling, it's probably not the best. But I mean, there's nothing wrong with that, right? Like we still have human teachers that can help if you're struggling the most. But maybe like if you need more practice and you kind of almost have it, and you tend to forget steps or something,
Yeah.
at
Yeah.
least in this very first go through.
Sure. Sure. You think of the zone of proximal development. And for anyone watching out there, the zone of proximal development, this guy named Vygotsky came out with this theory of basically what is the frontier of your knowledge? Like how far do we have to push it to put you in that space that's just beyond sort of the grasp of whatever topic it is that we're talking about right here, right? So if thinking about if this was you're on your zone of proximal development, right? And you're trying to teach this process to a student. Like, how are we kind of selling them short by doing the process for them? You know what I mean?
Exactly. Like I
Um,
think it's good if you're not having to stretch, or the way they have it set right now, it's like if you're not having to stretch too far, but you still need to stretch a little bit.
right, right. And I think a part of the finesse of a good teacher or tutor is they're able to intuitively understand where that zone of proximal development is how much further do you need to push them, like what do they already got, we can just keep moving forward and constantly calibrating to understand. And so it doesn't have a lot of context about who
Yeah.
you are and what you know, right, to be fair. um,
Right.
and so maybe if there was more sort of assessment, of a student of like of this type of equation, how much do they actually know, right? So something that kind of front loaded that to calibrate, right, where they are would
Right.
be
Right.
useful in this kind of context. Um,
Yeah. And the tricky part is if you're a teacher there with the kid, or even probably over Zoom, you can probably also sense like their level of frustration, like
yeah,
even not
yeah,
kid to kid, even kid between themselves, right? Between
sure,
one day and the next, or how tired you are,
right.
how close is it is
Or
to
they've
snack
checked
time,
out, right,
whatever. Yeah, exactly. Right.
right.
There's all of
Yeah,
that.
that's a great point. All the nonverbals that are available to a teacher or a tutor that might be working on this kind of stuff. Ideally, they're responding to that kind of thing.
Yeah.
ChatGPT is not there yet, but maybe in the future, they've shown the video mode, right? That does real time video. And
Yeah.
so if you have real time video, maybe you can be watching as a student gets frustrated or checked out, or you can see they're on their phone or whatever, and it could automatically prompt them to re-engage. Um, Another thing that um, I think is important that it does not do, as I was playing around with this before, ask it some kind of random anything. Ken, ask it, you know,
Uh, First is round.
yeah, right. And so when a student gets sidetracked and goes to another place, it follows, right? It doesn't
Oh,
sort of
right.
bring them back to what we were working
Right.
on before, right? So for
I
people with
was say, like, are
ADHD,
you supposed to be doing math right now? Like,
and so for people with ADHD like me, sometimes getting off track and going on this exploration thing and talking about how we know the Earth is round, that's fantastic. But if we're trying to get homework done, right? If it was able to redirect and bring us back, I mean, this goes back to like curriculum, And like if we're trying to adhere to a curriculum, specifically a math curriculum, ideally at this point it would redirect you back to
Yeah.
whatever you're supposed to be paying attention to, right? Yeah. Like yeah, we could, I mean it, and this is totally, in the world of distraction that we live in now, if you could have a tool that helped, and that's part of what we've done in our work, is looking at how you can productively redirect a student back to whatever they were trying to do at the outset, right?
Right. Right.
Um, yeah. Okay. So this is very interesting. Um, and so we went through that equation. Do you want to try a more general STEM topic next? Do you want to try another math question? What do you want to do?
Yeah. Let's do this. Maybe we can ask it. Here. Can think through to a wooden spoon feel like different temperatures.
Oh, great question. All right. All right. Yes, this is an awesome thinking question. Totally the kind scientists or middle school science teachers love to explore. Let's start from what your body is telling you. When you touch a metal spoon, the wooden spoon in the same room, the metal one feels colder. But they are actually different are they actually different temperatures? What do you think? Are the spoon temperatures different, or is it something else? Okay, so great. We have a great open-ended question to explore this space. So it seems like the pre-prompt is really heavy on asking questions. Okay,
Yeah.
so all right, let's see where we go here. Where is it going to take you? Um, so what do you think? Are the spoons
I want to ask, like, shouldn't the same temperature feel the same?
okay? Totally fair instinct, same room, same temperature. Shouldn't they feel the same? Right?
So it's like, this is a very interesting hint about this sensing heat transfer.
Yeah. Okay. So now we've got a new concept. We've got heat transfer, how fast your body heat moves into the object. So let me ask you this: which one, wood or metal, do you think? Let's a binary question here. We have
Mm-hmm.
binary question. Not great. I think, hanging on to the whys or the whats or the hows. That's what I like to see. Do you think let's heat move through it faster? So I think being more thoughtful about the types of questions it asks, I think would be better here. This is key to figuring it all out. Okay, so what happens when you guess one of the two? Let's see. Are you gonna? Yeah, I mean, you don't have to respond to the binary question. That's the other nice thing about the large language models. You can do anything you want at this point. Okay, it's easier to cut through wood, so heat should go through wood. Okay, yeah, wood faster. Excellent. Okay, so this is an interesting observation. Uh, that's a smart connection. Thinking about how easily things break or move feels related, but heat transfer doesn't quite follow the same logic as cutting or crushing. Um,
It's almost doing the same thing as it was doing on the math question.
yep, right. So it's doing a lot of the processing. I feel like the original intent of study mode here was to really put um, the obligation for the processing of the question or the problem onto the user. I think that was the original intent, but we're still
Mm-hmm.
doing a lot of the processing on the large language model. Um, Here's the trick: metal is a much better conductor of heat than wood. Okay, so now we're getting to this idea of heat conduction and so forth. That means when you touch the metal spoon, your body heat flows quickly into the metal, right? With
Yep.
wood, your heat stays near your skin because wood is a poor conductor. It's actually an insulator. Okay, so conductors and insulators, we're getting into these topics. I would have really liked to have had it lead me into what those were a little bit better.
Right. Right.
Introduce that material a little bit more elegantly. Um,
So maybe you do this, or I find myself doing it sometimes when we're getting to teach a lesson, but maybe you've done the same thing, is where you really do start with these very strong intentions of we're going to go deep, we're going to really draw out explanations, and then, you know, 45 minutes into your 50-minute class, you're like, okay, I'm just going to tell you because we only have like
right.
4 more minutes before we
Right.
need to be putting our stuff away.
For
But it
sure.
feels, which is the weird thing,
Yeah.
because chat has all the time in the world. It shouldn't, like, to me in my
Yeah.
head, it's like it shouldn't care how long it takes me to learn something. It should
No.
be so
Right.
uber patient.
Right. Right. And
But it
it
really
feels
feels, yeah.
it feels very goal oriented, right?
Yeah, it's like let's move along. Here,
Yeah,
let's
right, exactly, exactly. And there's so much more you could do with heat conduction and so forth and insulators and so much and like thinking about how those things work. And it is typically ending with a question here, right? If metal pulls heat from your hand quickly, what do you think it would feel like in a hot soup compared to the wooden spoon? Okay. Not, I mean, I don't know. I don't know about that question. I don't know if that's quite, I mean, obviously it's going to be hotter, right?
yeah, yeah. But it wouldn't just, oh, now that's an interesting question. If we had, if we were measuring the temperature, like say we had an infrared thermometer
Mhm.
and we were reading it, the temperature of the surface of the spoon, and we pulled them both out of a soup, I guess they would, at the very beginning, it should be the same temperature, right? And then
Yeah,
this might lose its heat faster because of the insulation.
sure. Yeah, I mean, and um, I would like to see something about like excitation of molecules eventually here as
Hmm.
well, and how that is spread from matter to other matter when it makes contact. That's where I'd like us to ultimately get, but I don't know if it's going to do it that at this level.
Let's see.
So
I think
again, it's kind of a not a binary question, but it's not a very open-ended question. And I think the strength of these tools is that how robust they are to open-ended questions, right? You can really open it wide up with these kinds of things. They don't have to be binary or, closed in any way, really.
see if it can answer these questions.
Thinking like a scientist now. Great question. If both spoons are sitting in the same pot, hot soup for a while, they'll both reach about the same temperature. Thermal equilibrium with the soup. Okay, great. The metal spoon feels hotter because it transfers heat to your hand quickly. The wooden spoon feels warm, but not as hot because it transfers heat slowly. There's those M dashes, right? Those
Yeah,
notorious M
yeah.
dashes that
Yep.
are suddenly everywhere as people are using these tools. Nobody knows how to type an M dash, yet suddenly people have them everywhere in their writing. So you're right again. Even though temperature is the same, what your hand feels depends on how fast the heat moves. Right. I like the emphasis that it puts on there. Want to try a mini review? Okay, so you're assuming that I already have it. You want to
Right.
review this material and apply this idea to something like oven mitts or winter clothes. See, now I would have wanted to say like, how does this parallel winter clothes, or even closer to the
Uh-huh.
context, like, why do you think people wear oven mitts, right? Why is that
Yeah.
happening, right? I want some whys, and I want to see some like broad, open-ended questions. Like, let's really explore this kind of phenomenon, right? Um, but it is making the assumption that like now it's time for review. All right, 1, 2, 3, let's go.
Right. Right.
Yeah,
we're paying for these servers. We can't.
yeah, right. Yeah, come on, come on. Let's chop chop, right? rather than like the open-ended exploration like you were alluding to. We have all the time in the world to explore this phenomenon that touches everything, right? And so much context that you could add or include or explore here of how energy moves between matter.
Yeah.
So much. Um, okay, so that's interesting. And any more on that one, or you want to try a different one?
Hey, let's try something different. You have another topic we should learn
Uh,
about?
well, we could talk about um, why the sky is blue.
Oh, okay.
So I want to hear something about Rayleigh scattering. I want to see, I want to talk about wavelengths of light, and I want to hear something maybe about sunset and the different colors that you can see in the sky, and how those things are all related. Um, why sky? You could even have like a question on my homework: ask why the sky is blue. Right? So this is explicitly you're not supposed to tell me the answer on my homework.
Yeah, let's try it.
Right. Ooh, it's a classic question. I promise we'll figure it out together, not by just giving an answer, but by breaking it down so you actually get it. Okay. Well, there's more than breaking it down for me to get it, right? Let's
Yep.
start with this. The sky looks blue during the day and orange and red at sunset. But why? Okay. We need to understand two things first. What is sunlight made of? What happens when sunlight hits the atmosphere? All right, step one. So it's very regimented in this process.
Yeah.
Remember what colors are in white sunlight? Hint, think rainbows, okay? What colors are hiding inside white light? So
Right.
it kind of, all right, so it did something there of,
Yellow, green,
yeah,
blue,
and brown. Try brown. Put brown in there, see what happens.
brown, and
and,
gray.
and gray. Okay. All right, nice start. Nice start. But you got most of the real rainbow. Let's clean it up a bit. All right, actual rainbow colors in white sunlight are red, orange, yellow, green, blue, indigo, violet.
Nice.
Roy Guv. Biv. All right. Uh, Now here's something cool. All those colors are actually light waves of different wavelengths. Okay, so electromagnetic spectrum. That's a huge topic, right?
Yep.
And maybe if it would have asked me if I knew what that was all about, right? Wavelengths of light, like how do wavelengths work and so forth. Again, so it would have a little bit more context about my knowledge that I would have brought into this space, right? Do I already understand wavelength or not? This is entirely new to me or not, right? So if it were more able to calibrate what my current level of knowledge was in the space, I would have liked to have seen that. Okay, but here we go. So red has long wavelength. If I don't have wavelength, I'm already lost. Blue and violet have short wavelengths. Okay, so now we're going to step two. Moving on, cranking through, right? Um, but
You only get 4 screens maximum to learn anything.
yeah, right. Yeah, otherwise it's just wasting time, right? But so if I don't have wavelength at this point, I am totally lost.
Do you
Uh,
think physicists also would be driven crazy by like it has a long wavelength and these have short wavelengths instead of longer and shorter? Because like
great
compared to like
point.
ultraviolet,
Right,
blue, violet don't have short wavelengths, right? Or compared to infrared, it probably has red as a shorter wavelength. So
right, right. And so that's a great point. And sort of like, what is your reference point? Right, it's all relative from here. Um, so yeah, so we have light waves and wavelengths. And if I don't already have that prior knowledge, I'm lost. This is really unfortunate. And it's already moving on to step two. All right, when sunlight hits the atmosphere, runs into gas molecules and dust. If I don't have gas molecules, then I'm sunk here as
right.
well. Um, which kind of wave do you think gets scattered more? Long wavelengths like red or short wavelengths like blue and violet? Just take your best guess. We got to move on. Right.
What do you think?
So again, that question is a binary decision here,
Oh
right?
yeah, exactly. Comes up
So
again.
right, and so why is it not asking the whys and the hows, right? That richness of understanding, allowing that student to, because you could answer with one word here. You could just say short, right?
Yeah.
And it would just keep going, right? Without any kind, you could just guess one of the two. Um,
It
yeah,
says,
right. Oh, you got it exactly right. All right, you must currently you know all of this, and that's its kind of as far as it assesses your knowledge as the user. Shortwave lengths like blue and violet get scattered much more in our air through the atmosphere. Scattering has a fancy name called Rayleigh scattering. I'm not sure if I'm pronouncing that right. I believe it's Rayleigh scattering. Now let's put that together. During the day, the sun high in the sky, the blue light from the sun gets scattered in all directions, way more than other colors. So no matter where you look, you see blue light coming from the sky. So when the sky looks blue, boom, done, learning complete, right?
right. I want to see if we wanted Raylene. Okay.
Okay, there we go. Yeah,
Oh, but here it brings us back. Like, all right, don't try to distract me here.
yeah, right. Now back to our sunset puzzle. Want to take a guess? At sunset, does the sunlight pass through more air or less air to reach you than it does at noon? Okay, so we have a little bit sort of spatial thinking about where you are relative to the sun and where the atmosphere is relative to you at sunset. But
Yeah.
again, binary question, more or less. So, that's a bummer that it seems like a really relatively superficial level to assess knowledge. Just again, more or less.
Let's see what it says. Like, it
Yeah.
would be nice if if the learner's like, this is just a guess.
Yep.
We'll see what happens.
Right. But if great guess, you're right on here. It's more. Okay. Here's why. Blah, da, da, and that's why sunsets look warm and gold, not blue, right? Okay. So a mini review to lock it in, right? So it sounds like in the pre-prompt, it has that like review step somewhere in there as well,
Yep.
right? Okay, review their knowledge, and then just keep going. Or okay, here's another question. This is great. Or do you want to try explaining it back to me like you're teaching it? Now that's nice. That's a nice step. So teach me your knowledge, right? So to clear up any kind of misconceptions that you might be having. Um, that's a nice step. I like that, right? Because I don't think the mini review is really the way to do it. I think really
Yeah.
kind of capitalizing on the discussion. How can we use this discussion format to really um, assess knowledge? And it's not quite doing that.
So I don't quite. If did we say why at noon? So from this explanation, it seems like oh, it just said it. But from down at the bottom, it's like oh, the extra air is scattering out the blue light. But then you would think like, well, at all times the air is going to be scattering out the blue light because blue light gets scattered more easily. So why isn't it always red and orange?
Ask it. See what happens. See how it does. Let's really zoom in on that idea. You're asking if blue light gets scattered, then gets scattered away from the sun. Then why don't we just see the other colors all the time? Let's think about this in two steps. Where does the scattered light go? When blue light gets scattered, it doesn't disappear. It gets bounced in all directions. So even if you're looking directly at the sun, you're surrounded by scattered blue light. That's why the whole sky looks blue during the day. Why not red, orange, yellow all day? because those longer wavelengths don't scatter much. They mostly pass straight through the atmosphere and go toward the sun.
How? What?
Yeah, that's go toward the sun. You mean away from the sun?
I don't.
Towards the earth.
I don't. Yeah.
So unless you're looking right at the sun is low on the horizon. Like at the sunset, you don't see much red, orange, and yellow light during in the sky. So a little bit of a misconception there, I think, unless we're radiating energy out back at the sun, which maybe I am. Yeah, no, I'm just kidding. Uh, so let me check with you. So it does this check review level. Let's see here. Go ahead and scroll down. See. So why does the sky look blue when the sun is high? Can you explain it back in your words, right? So put it in your words. That's a good prompt. Totally
Yeah.
use the Raji Biv, if that helps. Raji Biv.
I wonder. Like, let's. Is there?
Oh, so this is another feature for those of you who haven't tried this yet. ChatGPT can, of course, make images, but now it can make diagrams more accurately. Hopefully, we'll see what happens here. Let's see. Go ahead and do it. All right. The sunlight coming towards the Earth, the atmosphere around the Earth, blue light getting scattered in all directions, red yellow light going mostly straight through. View around Earth, seeing a blue sky during the day, and red orange light during the sunset. Let me make you that diagram. One moment. Okay. I've done this sort of thing before and it has failed spectacularly before. So let's see how accurate it is.
Well, I'm also interested. Like, are you going to try to show everything in one diagram? Anyway,
Yeah.
we'll see.
Right. Right. Yeah. Um, Now the iteration with this kind of thing is now been made a lot better. It used to remake the entire picture, and now it is more capable of remaking a single element within that picture, which is really nice. Or just making sort of subtle changes. It's very, very cool.
That'd be awesome. Is it just shows like a gray sky, and this is what it always looks like when it's cloudy. It just like avoids the whole thing.
Yeah, right. Right, right. And it's much better with language. So the image generator used to be really bad with language and sort of hilariously bad with illustrations that had annotations on them. It would just make up words. It would also fail spectacularly on that one. And so hopefully we're going to see in real time how well this does. But yeah, we'll see.
It's so interesting the way it's being built, sort of line by line almost.
Right, exactly. It's got kind of a kids book illustration sort of vibe to it. So we'll see here.
It's like the sun is rising into the sky.
Right. Yeah. All right. Well, that's brewing up there. Um, I don't know. I think it just needs to do a better job of assessing where the student is, like what their
Yeah.
background of knowledge is, to get a little bit more context about oh boy, here we go. Wow. All right. So we got sunset and it's still messing up the language. That's crazy. All right. So sunset, it's a little high in the sky to be sunset, but we got blue light scattering all over the atmosphere, blue sky, and the atmosphere word looks like we got a little bit of Russian mixed in there. It looks like
Aimless.
atmosphere, yeah, right. Sunset is pointing out into the distance. Not really sure what that arrow is pointed at. Red and yellow light, not quite clear where that's going. Um, so it gave it a shot. It doesn't seem like it's quite there yet. And
it is so interesting to me, like the it started off the whole thing with like the sun is putting out white light because it's made up of Roy BGB. But here in the diagram, it's using like sort of the very artistic yellow sun
Right.
and yellow rays of light coming in.
Sure, sure. Yeah, and I've seen sort of similar illustrations of Rayleigh scattering that were made by artists and being a little bit more intentional. My understanding is that they're having to be very careful with avoiding certain overlap of different artists and so forth, and it can't directly like
Yeah.
recreate certain images and so forth because of all kinds of copyright fights that they are currently having with OpenAI and every other creator, and so it's unclear as to how much of that is sort of interfering with its ability to accurately depict some kind of phenomenon like this. But nonetheless, it's pretty good. It's not there yet, but it's pretty good, right?
Yeah.
And if you wanted to, maybe we don't take the time to do it right now, but if you wanted to, you can make corrections. You can go back to it and say, fix the name atmosphere, ensure that it's logical, that the arrows are pointed where the arrows need to be going, and so forth. But it is not doing that yet. So interesting. Yeah. So with that, anything else you want to try for the time being? Can wait till Elise gets back here and we can try some.
Yeah.
Yeah.
I'll try some more math with her next week.
Sure. Yeah. I don't know. What do you think? So what's your assessment overall, Ken, for study mode for ChatGPT?
Like, I think it's pretty good in that it doesn't just jump to the answer. Like that in and of itself, I think is a good step forward. I just hope that whoever, teachers or parents, don't think like, oh, well, it won't give the answer. You can just use this to learn from. Like that's not true.
Right. Right. It's not there yet. Right. For sure. Yeah. It doesn't have any context about prior knowledge or anything like that. It doesn't have that kind of intuition that teacher or tutor might have. But yeah, I think as a teaching tool, at least it is a step up from the normal model, which just always gives you the straight up answer for any kind of math or STEM related kind of question. So it seems like this is a good first step to try and make their tool a little bit better, a little bit smarter with regards to pedagogy, but if they could borrow a little bit more from good sort of educational theory and so forth, I think it would really improve.
Yeah, I'm very someday it would be very interesting to talk to their designers about, like, it really does seem like, you know what, the users only want 4 slides to actually get to the answer. Even if they're using study mode, let's do it in 4 steps or something like that.
Sure. And I wonder about sort of like the majority of math questions that it was trained on that has the step-by-step logic. Did most of those have 4 sort of steps, or what is the incentive that it takes just that many steps and it moves along in such a way? I think it will be especially hard for them to really make it wait, right, for the individual, for it to develop a meaningful understanding of the material and be able to accurately assess if that they really have it or not, and then move on, right?
Yeah.
But yeah.
Well, and they also made the choice, like, you might ask, well, why are you asking? Or like, like, we're in study mode. It's perfectly fine to ask a learner, like, tell me a little about what you're trying to learn. But it didn't ask. It just is like, okay, we're gonna solve this problem.
And to its credit, there's plenty of teachers that
Oh yeah.
kind of do that, unfortunately, right? But like as you were alluding to before, is like we have all the time and space in the world. Like let's really think about good teaching and how you can make this a really effective teaching tool. What kinds of questions would you ask? Again, the questions we're asking really kind of binary, kind of superficial questions when you could have asked really robust questions. And if you had appropriate context, really focused, tailored, really on that zone of proximal development that the student brings to the space. So kind of a missed opportunity with the questions it was asking to assess knowledge.
Yeah, yeah. I mean, that was it. It's kind of crazy, but maybe not probably next generation, but a few generations of study mode from now,
Yeah.
you could imagine that you could have such a patient instructor, far more patient than almost any human could be, because humans are like, I'm done with this.
Come on. Right.
Right? But the computer, if it just kept on going,
Yeah.
knows what kids or whatever, how long they could go into it, right? Like,
Right.
it'd be great.
Yeah. Right. And just this sort of ideally of just this totally organic movement to the next level, right? That is entirely student directed. That would be amazing if we could make that happen. Yeah.
It's like it's more human than I would expect at this point. It's like, all right, we gotta go. We gotta get on here.
Right. Okay. Well, any closing thoughts at this point, Ken? Anything else you want to try with it, or?
I think this is the first time I use study mode, so
Yeah.
I'm excited for us to play with it a little more as time goes on.
Right. Me too. All right then. Well, for those of you at home tuning in to watch this, go check out Study Mode. Go see what works and what doesn't. See how effective it is in your domain of knowledge, and see, be mindful of the kinds of questions it's asking and how it might improve those. And perhaps this might be an asset to you in your classroom, in your educational environments. And yeah, just give it a try. Thanks again for tuning in to TERC Tech Talks. Anything else, Ken? Closing thoughts?
Don't forget to subscribe right down there.
Subscribe, that's right. All right. And we will see you on the next one.
It's time for TERC Tech Talks Top Takeaways. Study mode really is a great advancement for its use in education. Not just giving away the answers really is a big step forward. Secondly, the study mode really is for studying. It's not yet ready for, or maybe just not designed to support deeper conceptual understanding and learning from scratch. Our third takeaway is that it really did feel like it was rushing us along to get to a solution in 3 or 4 steps. The last takeaway is study mode really struggled with the diagram, and that's a feature that we will definitely want to see to better support learning.